Hello, my name is Ashley Goodnight, and this is my Week 6 reading review for Physics 2212. In this week's EDX videos, we had three main topics. First, we learned about magnetic dipoles, then we reviewed potential energy. Finally, we finished it out with multiple videos on electric potential. Last week, we began discussing magnetic fields. We continued this topic looking at a current loop. We are now given an equation to solve for the magnitude and direction of the magnetic field when our observation point is on the same axis as the center of the current loop. We introduced a new variable, mu, equal to the current times the loop area, which is our magnetic dipole moment. We also covered the case where our observation point is on the perpendicular axis of the center of our current loop. Similar to electric fields of electric dipoles, the magnitude of the magnetic field is half of the magnetic field of the on-axis case. As for the direction, the magnetic field points in the opposite direction of mu. This week's discussion of magnetic dipoles extended past current loops into bar magnets. Again, we also looked at the parallel and perpendicular cases. Moving on to this week's video about potential energy, there was a review of previous physics lessons from Physics 2211. We discussed the energy principle and gravitational potential energy, using the example of a ball falling towards the Earth. After the review of gravitational potential energy, we applied it to the material we have been working on, electric fields. In a similar way, the change in electric potential energy is equal to the negative work done by the electric force, found using an integral. We find three different cases involving the direction of the radius and electric force, modeled in the diagrams below. Finally, we also covered a new concept of delta V, which represents the change in electric potential. Similar to the electric potential, we again have three different scenarios shown below. This week's lessons apply directly to my major, electrical engineering. At Georgia Tech, EE majors select fields or threads to specialize in. Two in specific, telecommunications and circuit technology, have required courses that build off what we're learning in this class. Those who follow telecommunications take ECE 4350, electromagnetic and microwave applications, while students studying circuit technology take ECE 4391, electromagnetic compatibility. That wraps up my introduction to Week 6. Thank you for listening.